Hello, students. Let's get to work. This assignment is 8.7.3 practice problems. And before we do any practice at all, I want you to remember base 10. So let me make a chart that I've already showed you in class, but you need to be very familiar with this. Follow along on your own paper. I want you to start with 10. Okay, number 10. And that is 10 to the first power, right? 10 equals 10 to the first power. Easy enough. Now, I'm going to multiply by 10. When I multiply by 10, I get 10 to the second power. That equals 100. I'm going to multiply by 10 again, and I get 10 to the third power, which is equal to 1,000. Multiply by 10 again, and I get 10 to the fourth power, which equals 10,000. When I did this in class, a very impatient student spoke out and said, "Miss, we already know that the number of zeros is equivalent to the value of the exponent. See, Miss? 4 zeros, so the exponent is 4. I said, "Great, I'm glad you already know that. So you're definitely ready for what I'm going to teach next." That was multiplying by 10. Well, what if I go the other direction and I divide by 10? So now I'm going to start over here at 10,000, and I'm going to draw my arrow the other direction to divide by 10. So 10,000 divided by 10 is 1,000. 10,000 divided by 10 is 1,000. And 10 to the fourth divided by 10 is 10 to the third. So each time I divide by 10, my exponent value decreases. Each time, let me say that again, each time I divide by 10, my exponent value decreases. Let's do it again. I'm going this way now, divide by 10. So take 1,000, or 10 to the third, and divide by 10. Then I get 10 to the second, or 100. Each time I divide by 10, one of the zeros falls off, and the value of the exponent decreases by 1. Okay, so far so good. 100 divided by 10 gives you 10. And 10 squared, or 10 to the power of 2 divided by 10 gives you 10 to the first power. What if we keep going with this pattern? The value of the exponent decreases by 1. So then what is 10 to the 0th power? It is equal to, take 10 and divide by 10. 10 divided by 10, I'll write it right here. 10 divided by 10, that equals 1. 10 divided by 10 equals 1. This is something new. Now you know that 10 to the 0th power equals 1. And this chart shows you where that comes from. If you follow the pattern, then as you keep dividing by 10, then 10 to the 0th is 1. I'm not finished yet though. What if we divide by 10 again? Then we have 1 divided by 10. And that equals 1/10 in decimal. The exponent is going to be -1 because I keep going with this pattern, keep taking away one value of the exponent. So I went from 10 to the fourth down to 10 to the third to 10 to the second, 10 to the first, 10 to the 0th, 10 to the -1. When we get into negative exponents, now we're dealing in decimals. We're going to keep going. You need to learn these. So take 1/10 and divide by 1. Let me say that again. Now, 1/10 is 1 divided by 10, right? 1/10 is 1 divided by 10. What if I divide by 10 again? Then it is 1 divided by 10 divided by 10. And we have 2 10s in the denominator. In the denominator, it's 10 times 10. But what that means is 1 divided by 10 and 1 divided by 10 again. The value in decimal is 0.01. It's 1/100th. And in exponent notation, it is 1 to the -2. I'm just going to do one more, and you should be doing this on your paper. Now, let's divide by 10 again. So that's 1 divided by 10 3 times. Look again, 1 divided by 10 3 times. So 10 times 10 times 10 in the denominator. What is that in decimal? It is 1,000th. It is 1,000th, and in exponent notation, 10 to the -3. What I want you to realize is that every time we divide by 10, the value of the exponent decreases. And every time we divide by 10, our decimal moves over. That's the opposite of multiplying by 10. When we multiply by 10, the exponent increases. When we multiply by 10, we add on another 0. Okay, now I want you to look at your assignment. I hope that you have already clicked the link and opened it up on your screen. This is assignment 8.7, lesson 3, practice powers of 10. You'll find the link in the Google Classroom, just where you found this video link. Go and open it right now if you haven't yet. The first problem says, write the expression with a single exponent, and they give you 10 to the 7th squared. They want you to write it as a single exponent. Okay, in your notes, go ahead and put example. Now, in order to write this as a single exponent, it might help you to write it in expanded form first. So let me show you expanded form. This is 10 to the 7th, which is 10 times 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 10, because I'm going to do that again. 1, 2, 3, 4, 5, 6, 7. Oh, exhausting. There, that's 10 to the 7th squared. You can count up the tens and easily see this equals 10 to the 14th. You can write it out in expanded form and then count up the tens. If you want to write this as a number, it's 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. But nobody wants to do that. So you need to use an exponent. Well, even easier, you need to recognize that when you have power to the power, 10 to the power of 7 to the power of 2, you multiply your exponents. So the number of zeros is 7 times 2. This gives us power to the power rule. Please write this in your notes. Power to the power rule. This is an exponent rule. Some number x to the power of m raised to the power of n, so we have an exponent on an exponent, that simplifies to x and then multiply m times n. I'm using letters to show this rule, but the letters can be any number. Please write that power to the power rule on your paper. And then go to the assignment to enter your answer. But read it carefully. It tells you use the caret symbol to represent an exponent. So your answer, look at my paper please, 10 to the 14th using the caret symbol is 10 caret 14. And on your keyboard, the caret symbol is Shift 6. Go ahead and enter that right now. And submit your answer. There are 5 more problems like this. You need to use what you learned to simplify this power to the power expression. I don't want to give you the answers, so I'm going to cover that up while I enter them quickly. You should pause the video and do the work now. I'm not giving you the answers. You've got to use power to the power. Just multiply the exponents. Don't forget the caret symbol. Pause the video. I'm going to do it real quick though. And then come back when you're at the next problem. This one needs a little bit of explaining. It says you have 1 million number cubes. So I drew a picture of that. You have 1 million, and they called it a number cube. I think they mean dice, right? So here's my dice, but they called it a number cube. Each one of them is measuring 1 inch on a side. So I labeled that each side is 1 inch. The question asks you, if you stacked the cubes on top of one another to make an enormous tower, how high would they reach? So I drew this little diagram, and it's 1 inch by 1 inch by 1 inch by 1 inch by 1 inch. Each one is 1 inch, but there are 1 million of them, just like the problem says. So how tall would it be? How high would it reach? Give your answer, but don't include the units of inches. So you're not going to say 1 million inches. You're just going to type in the number. And if each one of them is 1 inch tall, then you know it's going to be 1 billion inches high. Now you can't see my answer. I hope you listened. And then submit your answer. Then they say, explain your reasoning. So, okay, I'll help you with this part. If each inch, each cube is 1 inch tall. So all together, they are 1 million inches tall. I said so all together, I mean so stacked. Let me change that. So stacked up. So stacked up all together, they are 1 million inches tall. Okay, next question is a little tricky, and I got this wrong the first time. If you arranged the cubes on the floor to make a square, would the square fit in your classroom? Let me tell you why I got it wrong the first time. Look at my paper. So here's a grid of all these cubes arranged in a square, but the first time I thought they meant only a perimeter, a square. I didn't know they meant like a flat filled in square. So I got it wrong the first time. This is what it should be though. You have a line of cubes, a line of cubes, a line of cubes, a line of cubes, and so on and so on and so on, but there's 1 million of them. So if you fit 1 million of them into this grid pattern, this square, it asks you, would the square fit in your classroom? Well, if there's 1 million squares, then that has to be like 1,000 of them this way and 1,000 of them this way. And I'll show you how I got that on the next problem. 1,000 inches? I don't think that's going to fit in my classroom. So I said no. Not in my classroom. Okay, next question. What would be the dimensions of one side of the square? Okay, so there's 1 million of these cubes all together, and they want to know, you need to calculate, what are the dimensions of one side? So here I'll draw in green, one side length, and I'm going to call that S. Okay, you need to remember that, I'll write over here, area of a square equals the side length times the side length. And we want to find out what is the side length. Well, the area is 1 million. And that's going to equal something times something, the side length times the side length. So what times what equals 1 million? Because this is a power of 10. Oh, by the way, you don't divide it by 2. This is S times S. This is not S plus S. This is S times S. S times S equals S squared. Anyway, what times what equals 1 million? Is it 100 times 100? No, that would only be 10,000. Is it 10 times 10? No, that would only be 100. Okay, well, look at this million, and then I'm going to draw a box around those 3 zeros, and I'm going to draw a box around those 3 zeros. That helps me see that 1,000 times 1,000 equals 1 million. Because when you multiply 1,000 times 1,000, you just add up the zeros to get your answer. So the side length is going to be 1,000. This is 1,000 cubes long and 1,000 cubes high. Go ahead and put in your answer. And then the next question asks you about volume. Oh, I'm sorry, it doesn't. It says explain your reasoning. Let me help you with that. Okay, so if the area, no, not if, I'm going to say the area, there we go. The area will equal 1 million inches squared, and 1,000 times 1,000 is 1 million. There we go. So that's how I got my answer. Submit your answer. Go to the next problem. Now it asks you about volume. However, it doesn't use the word volume. Let me explain. Look at the problem. It says, if you layered the cubes to make one big cube, what would be the dimensions of one side of the cube? So now we're going to take all these little cubes and stack them until they fit in one large cube. So I'm going to draw what that looks like. We have stacks and stacks of these little dice, all arranged. So imagine this is like 1 million little blocks. You know, you played with blocks when you were a kid. You know how they fit together and you could stack them into a cube. Now, it's asking what would be the dimensions of one side. All the sides have the same dimensions, so any side you want, I'm going to label that S. If this is stacked and it's solid with cubes, then I know the volume equals 1 million little cubes. The volume equals 1 million little cubes. I also know that the volume equals the side length times the side length times the side length. So I can now write 1 million equals side length times side length times side length. What times what times what equals 1 million? Is it 10 times 10 times 10? No, that would be 1,000. Let me show you. I said, is it 10 times 10 times 10? Well, no, because if I count the zeros, that's only 1,000. Well, then what times what gives me 6 zeros? What times what gives me 6 zeros? That's going to be 100 times 100 times 100. That's going to equal side length times side length times side length. 1, 2, 3, 4, 5, 6. 100 times 100 times 100 equals 1 million. So the side length must be 100. Please submit your answer and then explain why. Go ahead and explain. Let me help you. Because the volume is 1 million cubic inches. So 100 times 100 times 100 is 1 million. I said so, but I should have said and. And 100 times 100 times 100 is 1 million. Next question. This is kind of a biology question. You're going to love it. An amoeba divides to form 2 amoebas after 1 hour. 1 hour later, each of the 2 amoebas divides to form 2 more. Every hour, each amoeba divides to form 2 more. I'm going to draw a picture of this little amoeba here. And he starts there. Then after 1 hour, he has divided, he, she, I don't know, whatever, into 2 amoebas. 1 hour after that, which would be a total of 2 hours later, each one of those has divided. So then you have 4 amoebas. And this pattern keeps going, but it would be too hard to write it without exponents. So after 1 hour, you have 2 amoebas. After 2 hours, you have 2 times 2. 2 times 2, that equals 2 to the power of 2. After 3 hours, you have 2 times 2 times 2, which is 2 to the power of 3. Do you see the pattern? Every time it doubles, you times 2 again, so the value of the exponent increases. Read the question. They ask you, how many amoebas are there after 1 hour? So I have it in my picture. I'm covering my answer because I don't want you to just copy me. Look at my picture. How many amoebas are there after 1 hour? It doubled only once, right? After 1 hour, it has only doubled once. There was 1 and it doubled. Submit your answer. Next question. How many amoebas are there after 2 hours? So now it has doubled twice. Submit your answer. Then it says, write an expression for the number of amoebas after 6 hours. When it says write an expression, you're not going to give the exact number. You're going to use the caret symbol to represent an exponent. Write an expression in exponential notation. After 6 hours, that would be 2 times 2 times 2 times 2 times 2 times 2. So 2 to the 6th power. Type it in using the caret button. Ding! Can you see it? Ding, 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 ding. Okay, next problem. Now, write an expression for the number of amoebas after 24 hours. Use the caret symbol to represent an exponent. By now, you recognize the pattern. Every hour it doubles. So the number of hours is the number of repeated multiplications, the number of doublings. This is called exponential growth. When it doubles like that, that's exponential growth with a growth factor of 2. That repeated multiplication, 2 times 2 times 2, that's called the growth factor. Go ahead and enter your answer now. I'm not going to tell you. I want you to think about it and get it right. Then they ask you to explain why exponential notation might be preferable to answer these questions. Okay, let me help you. Exponential notation helps us write very large numbers and show exponential growth. Exponential growth patterns. Is it 2 T's? Oh, I got it, 2 T's. I'm not good at spelling. Submit your answer. Okay. Da-da-da-da. This one's a little hard. I honestly had to really think about this one, but I got it. You know what though? I need to go. It's like 6:30 at night. They're going to lock me in the school if I don't leave. Really quickly. Elena noticed that 9 years ago, her cousin Katie was twice as old as Elena was then. That was 9 years ago. Then Elena said, in 4 years, I'll be as old as Katie is now. If Elena is currently E years old, write that down. Anytime you get something, write it down. Oops, this is my next example. Elena is E years old. And Katie is K years old. Katie equals K years old. Which system of equations matches the story? This one's pretty hard, actually. It's not that simple. So, 9 years ago, Katie was twice as old as Elena was then, right? 9 years ago. Katie was, gosh, I have to think about this every time. I even did it. I did it twice. It's confusing. I'm going to get my notes. I remember now. Okay, so Katie, 9 years ago. This is Katie's age now, but 9 years ago, so that's K minus 9. 9 years ago, Katie was, her age was equal to 2 times Elena's age. Well, that's Elena's age, but 9 years ago. Look at this equation. Isn't that confusing? So Katie's age 9 years ago. K minus 9 means Katie's age 9 years ago. And E minus 9 means Elena's age 9 years ago. So Katie's age 9 years ago was equal to Elena's age 9 years ago times 2. She was twice as old as Elena. That's one piece of information they gave you. They also said, or Elena said, in 4 years, I'll be as old as Katie is now. Well, that was 9 years ago. So she said in 4 years, that would be 5 years ago. You can see that on a number line. Let's say this is now, 1 year ago, 2 years ago, 3 years ago, 4 years ago, 5 years ago, 6 years ago, 7, 8 years ago, there, 9 years ago, she said. She said, in 4 years, 1, 2, 3, 4. So now you can see that's, if she says in 4 years, then that was 5 years ago. In 4 years, I'll be as old as Katie is now. So that means Elena's age minus 5 would be equal to Katie's age minus 9. Right. So this means Elena's age 5 years ago would be equal to Katie's age 9 years ago. So here are the two equations that you need. Now, look at your options and figure out which two are the same as these. And I have to go before I get locked in the building. So good luck to you. I know the answer, but I'm not going to show you. You have to look at those options and click the correct answer. And then finish the assignment. See you later, guys. Bye-bye.